Hello, ladies and gentlemen, and welcome back. In this video, we're going to be taking a look at question number 7 on the 2008 Euclid Math Contest. So, first up, 7a, the average of 3 consecutive multiples of 3 is a. The average of 4 consecutive multiples of 4 is a plus 27. The average of the smallest and largest of these 7 integers, so I don't know what these 7 integers are. I could probably figure some of them out in terms of a. But the average of the smallest and largest of these is 42, and I think that'll set up the last equation because we are being asked to determine the value of a. And we do have to show our work for this one, but we were going to do that anyway, weren't we? So the average of 3 consecutive multiples of 3 is a. So I think the first thing to try and do, well, the first thing is get question 6 out of here. But the first thing to do would maybe start talking about these numbers. So multiples of 3, I'm thinking a is already in use. So how about we say 3b plus 3, and 3b plus 6. This would be 3 consecutive multiples of 3. And then we can have 4c, 4c plus 4, 4c plus 8, 4c plus 12 are our numbers. Okay. We don't have to justify that they're multiples of 3 or 4. That's clear from the setup. The people marking these things have been briefed on that sort of stuff. So, A is the average. Well, how do we average numbers? We add them up and we divide by how many. So this will be 9b plus 9 divided by 3. Very similar actually to b part, because we've got this is an arithmetic sequence here, and the average of 3 terms in an arithmetic sequence is just the middle term. But we get 3b plus 3. So a minus 3, a, and a plus 3 are the multiples of 3. Okay? So we don't need b anymore. That's done. We know that the middle term is a, then it's a plus 3, a minus 3. So a happens to be a multiple of 3. That's pretty nifty. Okay, and now we know that the average of my multiples of 4 is a plus 27, they said. So we add them all up and divide by how many numbers there are. There's 4 of them. So we're going to get 16c plus 4 and 8 is 12, plus another 12 is 24. Divide that by 4, and we are going to get 4c plus 6 is a plus 27. So what exactly could we say then here? I can get, so a plus 21 is 4c, a plus 25 would be 4c plus 4, a plus 29 would be 4c plus 8, and a plus 33, no, 33 is 4c plus 12. So, okay, I've got both sequences. So the two sequences are a minus 3, a plus 3, and a plus 21, a plus 25, a plus 29, a plus 33. It is very clear to see here that this is going to be the smallest, and this one here, a plus 33, is the biggest. And we're told that the average of the biggest and smallest is 42. So we add them up, divide by how many of them there are. There's 2. So that's going to be 2a plus 30 divided by 2 is 42. That tells me 84 is 2a plus 30. Subtract 30 from both sides. 54 is 2a. So a is going to be 27. And if you wanted to, you could do a little double check. Are these actually multiples of 3? Well, you'll have 24, 27, 30. And you'll have 48, 52, 56, and 60 here. And 60 and 24 do indeed add up to 84, and so we'll give you an average of 42. So it all worked out. We've shown our work. We've got our sequences in terms of A. We were able to pick the smallest and biggest. I'd say this is probably worth 3 marks, maybe 4. Okay, so that's 7A, but we still have 7B down here to look at. So what have we got to look at? So 7B, Billy and Crystal. Billy Crystal. Billy and Crystal each have a bag of 9 balls. The balls in each bag are numbered from 1 to 9. Okay. Billy and Crystal each remove 1 ball from their own bag. Let B be the sum of the numbers on the balls remaining in Billy's bag. C is the sum remaining in Crystal's bag. Determine the probability that B and C differ by a multiple of 4. Okay. So they each remove 1 ball from their own bag. So 1 ball gets removed. I'm going to give a name to that. Now, little b and little c are what I would probably choose, but those are being taken by definition in the problem. So I'm going to say something like, let b equal the number Billy chose, and c will be the number Crystal chose. Okay. So I don't know what b is, but I know that little b is going to be the sum of the numbers of balls minus the 1 ball that Billy took out. And just from experience, I know the sum of the numbers from 1 to 9 is 45. Of course, you can grab a calculator to work that out if you want to. Okay. So, now we want multiples. We want the difference to be a multiple of 4. 4 divides b minus c, but now I can say, well, that's really just 45 minus b minus 45 minus c. It's sort of, they're making me do a little extra step. This will then work out to be c minus b. They're doing an extra little step just to get at the balls that were chosen. By having little b and little c be the sum, I mean, it's not changing anything. It's 45 minus b and 45 minus c here. But they're just making me do a little extra step. So b and c differ by a multiple of 4 if and only if C and B do. Okay, so the question now becomes, can we find pairs B and C with B and C between 1 and 9 so that 4 divides C minus B? Now we're being asked a probability question. And anytime you do a probability question, you want the number, unless they're actually giving you weights, like saying, oh, well, it's twice as likely that ball 1 was picked over ball 3. But none of that's in this question. So it's the number of outcomes you want. Or you have named, or that you're interested in, divided by the total number of outcomes. So to compute probability, we need 2 of these things. This first one is the number of pairs BC, where B and C differ by 4. The second one is just going to be, well, there's 9 choices for B, 9 choices for C. So this is 9 times 9. This is 81 possible outcomes. You know, it's the outcome where Billy picks 1 and Crystal picks 8. The outcome where Billy picks 5 and Crystal also picks 5. The outcome where Billy picks 5 and Crystal picks 6. All 81 outcomes. So we're going to have a probability out of 81. It's important to remember, even for the written questions, that we're being at what we're actually being asked for. So we're being asked for probability. We want something out of 81. And now the rest of the question is just, what is this number on top? Okay. So, I think we've got sort of two options. Yeah, two options. No, I'll say three options. So 4 needs to divide C minus B. C is at most 9, B is at least 1. So C minus B is at most 8 and is at least negative 8. So we've got cases. I'm going to say C and B differ by 0. I was going to write it with absolute value. I think I'll just say it verbally. So they differ by 0, 4, or 8. That's the worst that can happen. They can't differ by 12 or something like that. So how many cases have B and C differ by 0? That tells me B is equal to C, and this is going to be 9 cases. B equals C equals 1, all the way up to B equals C equals 9. Okay, not particularly interesting. How about B and C differ by 4? So then B is C plus 4 or C minus 4. These don't overlap here. There is an order. It matters whether or not Billy picked out the 6 or Crystal picked out the 6. That sort of a thing. So we know C is between 1 and 9. So that means 5 is between C plus 4 and 13. Or, sorry, C plus 4 is between 5 and 13. Or in this case, negative 3 is less than C minus 4. Less than 5. But this tells me then B has to be between 1 and 5. Because I know B is between 1 and 9. So it's sort of we overlap this calculation and this calculation for B. So that's going to be 5 is less than B is less than 9. So this is 5 cases. And this is also 5 cases. So 5 of those C values lead to actual values of B in both instances. So that's 10 cases. I'm going to mark these guys in blue so it's easy for me to add them up. Although we really only have one case left. And that's differing by 8. So B is going to be C plus 8, or B is C minus 8. Well, I know that C is between 1 and 9. So in this case, that tells me that B has to be between 9 and 17. In this case over here, that means that B has to be between negative 7 and 1. But once again, remember that B also has to satisfy this inequality, so combining these two, we get that B has to be equal to 9, and in this case B has to be equal to 1, so that's 2 cases. Now we'll mark that in blue, but that's it. And the way we've laid things out, we have done it methodically. Okay? We said, it's 81 in total. We have shown that it's entirely about which balls are picked. The difference between those is a multiple of 4 if exactly when the thing that they actually wanted, which is little b, little c, the sum of the balls remaining in the bag, that differs by 4 exactly when the 2 balls picked out differ by 4. And then we showed, well, there's only going to be 3 cases. The balls differ by 0, 4, or 8. You could make that 5 cases by B minus C specifically being negative 8, negative 4, 0, 4, and 8 if you want to lay it out that way. But we did each case, and we worked through it, and we showed our inequalities, we showed where they overlap, and we got our solutions, and all the numbers are looking fine. So we have figured out that top number, And we can say something like, therefore, we'll keep it in blue for fun. I'm nothing if not whimsical. The probability that 4 divides b minus c. Did they specifically say the b and c differ by a multiple of 4, but that's the same thing. So the probability that 4 divides b minus c, that b and c differ by a multiple of 4, is, so it's 9 cases, 10 cases, 2 cases out of 81. So that'll be 21 out of 81. Multiple of 3, so that's 7 out of 27. And there we go. So we'll switch it back to black there, and yeah, nothing else to do for that question. We're good to go. And we will move on to question number 8, and that'll take place in the next video. Thank you guys so much for watching. I'll see you for question 8 next time.